Okay, so welcome to part one of graphing quadratic functions. And as you can see here, we're going to do it analytically or algebraically now. And so we're going to be graphing without the TI Inspire. And we're going to be using different formulas, factoring, and different methods that some of which you've learned in the past in order to be able to accurately sketch the graph of a parabola. Okay, so we know that the form of the equation of a parabola is ax squared plus bx plus c. A, b, and c represent numbers. A is the coefficient or the number in front of the x squared term, b is the number in front of the x term, and c is the constant. And what we're going to do is, using the equation plus a couple of formulas which will be given to you on assessments, you are going to be able to identify the key parts of a parabola and then find specific coordinates and graph those. Okay, so if we come back, here's our sketch of our parabola. Keep in mind that we're looking for several key things. We're looking for the vertex, we're looking for the zeros or the x-intercepts, we're also looking for the y-intercept. Typically what we would do then is use the symmetry of the graph. Remember, we have an axis of symmetry over here, which is like a fold line, and the parabola is symmetric about this line, which means if we take this y-intercept and reflect it over this line, we will get a corresponding point which will share the same y coordinate, and then we would just need to figure out the x coordinate. So this point would have the same height as the other point, and so its y coordinate would be c. And so what we're going to be able to do is first of all identify whether our parabola is going to open up or down. Then we are going to find the axis of symmetry, which we use the formula minus b over 2a, and of course the b and the a refer to the coefficients of the x and x squared term respectively. We will then use substitution, so when we find this value, the x value of the axis of symmetry, which is of course also the x value of the vertex or turning point, we substitute it into our equation to find the corresponding y value, and that's going to give us our vertex. X-intercepts are found using factoring, and lastly the y-intercept is found using substitution and the fact that along the y-axis the value of the x is 0, and so if you sub 0 into the ax squared plus bx plus c expression, you'll find the y-intercept. Of course, the shortcut is to recognize that if you sub 0 in the place of x, ax squared and bx will leave you with 0, and c is in fact the only thing left, and so c is in fact our y-intercept, and that's why you see the letter C over there. Okay, so just a quick highlight of a couple of things over here. The graph will open up if the x squared term is positive. The graph will open down if the x squared term is less than 0 or negative. Of course, if it equals 0, there is no x squared term and we don't have a parabola. And then, of course, if you multiply the x squared term by a number, that causes it to get wider or narrower. It gets narrower if the number is larger and wider if the number is smaller, specifically between 0 and 1. Here we have our axis of symmetry, minus b over 2a. In a future lesson, I'll show you where we get this specific formula from. And then the vertex is found by finding the x-coordinate and then substituting it in. Okay, and then of course any graph which opens up will have a minimum, just like this one over here, and that is what this states here. A graph that opens up has a vertex that is a minimum, and vice versa. If it opens down, it will have a maximum. Okay, and so what we're going to do now, there are details here of each of the steps that are required and how you find each of them, and that's more or less what I've been talking you through. And what we're going to do is jump ahead now to the first example, note without using your TI Inspire, and I'm going to go ahead and graph f of x equals x squared minus 2x minus 3, and the key here is going to be to find all of the key components of the graph and then sketch them and label them. Okay, so let's begin. What we can do, and there's no particular order to do this in, but one of the things we can do is begin by factoring that. And so we had a bit of a factoring review last class. So in this particular case, if we factor that, to get the x squared is x times x. Factors of 3, fortunately in this case there's only one pair, and that is 3 times 1. This tells us the signs are different, and so now we're going to have to figure out 1 plus and 1 minus. How are we going to get minus 2x? Hopefully you realize that we can obtain that by giving the minus to the 3 and the plus to the 1. We can do a very quick check. X squared plus 1x minus 3x will give us minus 2x minus 3. Of course, hopefully what you recognize is that these will give us the zeros or the x-intercepts. Specifically, x will equal 3 or minus 1, and those are going to produce zeros. And so those are going to produce our x-intercepts. Of course, this is our x-axis, and we have our y-axis over here. And so we have intersection points of the x-axis at 3 and at minus 1. Okay, so what we can do is, if you've got the x-intercepts, what you can find out actually really easily is the axis of symmetry. And remember, the axis of symmetry is the fold line. And the fold line is always going to be halfway in between the x-intercepts. So you can already figure out that for my axis of symmetry, our axis of symmetry is going to be x equals, and in this case, if we go halfway between 3 and minus 1, we of course end up at 1. And so x equals 1 is the axis of symmetry, which we have found using a characteristic of the graph. The alternative, of course, is to use the formula which says minus b over 2a. In this case, b is minus 2, a is 1, because the coefficient of the x squared term is 1, and of course c is minus 3. So if we were to substitute in minus b over 2 times a, you'll see that simplifies to 2 over 2, which of course is 1, and that confirms using our formula that our axis of symmetry is in fact at x equals 1. So what I'm going to do very quickly is just graph a line for my axis of symmetry that is going to go to through x equals 1. Okay, so now I've got part of the vertex. Of course, we've got 2 or 3 other key pieces that we need to find. The next key piece that we need to find is the corresponding y value because the axis of symmetry is of course only one part. We need to find the coordinates of our vertex. The coordinates of the vertex, in this case we've got 1. We need the corresponding y value, and to do that we can substitute into the equation. So we're going to say f of 1, I'm going to substitute 1 into the equation. That's going to be 1 squared minus 2 times 1 minus 3. That of course gives you 1 minus 2 minus 3, which gives us minus 4. And so minus 4, 1 minus 4 are the coordinates of the vertex or the turning point. And so if I go to 1 and minus 4 over here, this is the coordinate, the point where our parabola turns. Of course, if we've already established our x-intercepts, we already know that this parabola is going to open up. In other words, that vertex is a minimum, but that of course can be confirmed by the fact that the x squared term, the coefficient of the x squared term is positive, and that of course means that our parabola opens up. Okay, so we are almost done in terms of what we need to find. We found our vertex, we found our x-intercepts. Our y-intercept is the next thing that we need as per the instruction. The y-intercept, as I mentioned before, is when x is equal to 0, so that would cancel the x squared and the 2x term, and of course the easier, quicker way is just to identify what c is, which is the value that has no x squared or x, the constant, and in this case the constant is minus 3, and so that gives us our y-intercept, which is occurring at x equals 0, y equals -3. I'm going to start adding my labels in here now. My vertex is at 1, -4. One of my x-intercepts is at 3, 0, and the other one is at -1, 0. And we are now in a position to sketch our graph. Of course, the last thing we could do is just use the symmetry of the graph to find a point corresponding to the y-intercept. The y-intercept is 1 unit away from the axis of symmetry. So if I go 1 unit to the right, I will find a corresponding point, and I'm going to add in the label for that corresponding point, and that label, of course, is going to be 2 -3. And we now have 5 points and are able to graph a very accurate parabola. And so I'm just going to sketch, of course. Do not use a ruler, because this should be a smooth curve, turning over there, and try to be careful to make sure it passes through. We can stop there. You don't have to draw all the way up. We're going to put arrows on the end to indicate that the graph continues forever upwards in both of these directions. And we have now completed our sketch of our function with a vertex, a y-intercept, our x-intercepts, and our axis of symmetry, which we've drawn in here. I could just put a label in. Of course, it's a vertical line, and so its equation is x equals, in this case, 1. Okay, and so that's allowed us to sketch and label a very accurate graph of f of x without using our calculator. So at this point, what I want you to do is to attempt the second example on your own using the same method, and then come back and watch part 2 of the video in order to see how you did.